Alright, so number 7 says to find p to the nearest degree. So we're looking for, in this case we're actually looking for an angle. So on these other ones we've been looking for the sides of the triangle, but we can also use our SOHCAHTOA to find missing angles as well. So they give us actually the sides of the triangle, and they're telling us that we want to find p. And so this represents angle P. And so we use this, as we mentioned earlier, so we use this theta, that's just a Greek letter, just like pi, for an unknown angle. So like if you don't know what it is, just like with an equation, maybe we use x. If we don't know what a theta is, or an angle is, we call that guy theta. So it looks like a little circle kind of through a line through it. Alright, and then so what do we know? So let's label our triangle. So we always know the side opposite the right angle, that's the hypotenuse. And then the side between the right angle and theta would be the adjacent. And then the side opposite theta would be the opposite side. Now this one's actually a little bit of a different problem because we actually know all three sides, and then so you're like, well, which trig function do I use? Well, the short answer is you could actually use any one of them. Because you actually know all three sides, we could actually choose any trig function we wanted. So we could do opposite over hypotenuse, or we could do adjacent over hypotenuse, or we could do opposite over adjacent. Which one do you want to use? I don't know. Let's pick one. Let's go. I feel like we haven't used sine, so let's go with sine. Let me mix it up. Give sine some love here. So let's go with sine. So that means that we're going to be using. Now this doesn't always happen, by the way, that you know all three sides, right? So if you just know two of the sides, then you're stuck using those two sides. We just had it just happened to be that on this one we had a choice. Now sine of, I'm not going to write sine of 60 degrees or whatever it is, because I don't know what it is. So I'm just going to say sine of theta, because actually I don't know what the angle is. Now I do know what the two sides are, opposite, which is 12, over the hypotenuse, which is 13. Now again, go back to algebra, right? So you're trying to get theta by himself. Just think of, you don't need to write this down, but just think about a very basic algebra 1 equation. If I want to get x by itself, I look at what's on the same side as x, and I say, well, there's a 5 over here. That means I have to get rid of the 5. If I think of the same thing here, who's preventing theta from being by himself? Well, there's a sign. I got to get rid of this sign. How do we get rid of stuff? Well, in algebra, we do the opposite. So the opposite of multiplying is to divide. Well, the opposite, in this case, you might think, well, do I divide by sine? Well, so that actually, sine and the angle are kind of grouped together there. So what we do is that the inverse, to get rid of sine, we do the inverse, which would be sine to the negative 1. And what happens is that those two things, sine to the negative 1 and regular sine, they cancel each other out, and then I'm just left with theta. But then what I do to one side, I have to do to the other side. So I would have to do that. Right? So what does that look like? So on the calculator, you'll notice that there's regular sine, and then there's sine to the negative 1. So we use the inverse. We'll kind of make a little note here. So use inverses. And so that would be like sine to the negative 1, cosine to the negative 1, tangent to the negative 1, depending upon which one you're using. Use inverses to find angles. So you notice what happens is that on the others, like just go back to the last problem, for instance, we knew the angles. What we were looking for was sides. So that's why we use the regular trig functions. But in this case, we're actually looking for an angle, so we're using the inverse. So what that looks like on the calculator is, instead of hitting regular sine like that, we're going to hit second sine. And then we'll do 12 divided by 13. and we get approximately 67 degrees. And that's a reasonable answer. We'll do a little squiggly there for approximate. So approximately 67 degrees. That's a reasonable answer. What would not have been a reasonable answer is that let's say we forgot to do the inverse and we just did regular sine. So if you did sine of 12 divided by 13, you get an answer of 0.016. Well, that doesn't make any sense to say that angle is 0.01, right? So we can catch ourselves from making mistakes by asking if our final answer makes sense or if it's reasonable. All right, so go ahead and pause here and try number 8.